everyone, today I'm going to be showing you how to work through number 4 of the 2011 AP Calc AB free response question. So it gives us this graph here and states that the continuous function f is defined on an interval -4 to 3, and the graph consists of two quarter circles right here and a line segment right here, and it also gives us that g of x is equal to 2x plus the integral from 0 to x of ft dt, and part A says to find g of -3 and then to find g prime of x and evaluate g prime of -3. Before I move on, just make sure you remember that this graph is of f and it is not of g, and that can often be mistaken. This is also no calculator. You really don't need a calculator for this, and it is pretty straightforward, so let's get into it. So for the first one, g prime of 3, this is very simple because we're already given g of x. So simply plug in -3 for x and solve. So 2 times -3 plus the integral of 0 to -3 of f of t dt. So we have to reference the graph that was given to us and find the integral, which is also the area, from 0 to -3. And this is a quarter circle, so we know that the area of a quarter circle is 1/4 pi r squared. And in this case, the radius is -3, so that will give us 9 pi over 4. But it is negative because the integral goes from 0 to -3 instead of from -3 to 0. So keep that in mind because that will also be a common mistake for this problem. And next we have g prime of x. And since we're also given g of x here, we just take the derivative of g of x, and that'll give us g prime of x, very straightforward. So we know 2x will change into 2, and since taking the integral of something is taking the antiderivative of it, we are taking the derivative of an antiderivative, so that'll just leave us with f of t, but in this case it'll be f of x because everything will be in terms of x. And so now we just plug in -3 for x and solve, but we have to reference our graph one more time to see where f of -3, what that will give us, and it is 0. So it's 2 plus 0 is just 2. And for part A, we get 3 points, 1 point per each of these. So keep that in mind, and we're going to move on. B. Determine the x-coordinate of the point at which g has an absolute maximum on the interval -4 to 3 and justify your answer. Okay, so I wrote this for reference, and just as a reminder, maximum is where it goes from increasing to decreasing. So we have g prime of x, we already solved that here, and so we have to see where that equals 0 because that's where this shift will occur. So g prime of x is equal to 2 plus f of x. So we set that equal to 0, and we get that f of x is equal to -2. So now we have to look at this graph again to see where f of x could equal -2. And so that is right here, -2, and this line segment has a slope of -2 also. So the only place that f of x is equal to -2 is right here, which is 2.5, also known as 5/2. So x is equal to 5/2, and that is also the absolute max. But since it asks for us to justify our answer, we also have to state that g prime of x is greater than 0 on the interval of -4 to 5/2. So everything above here is greater than 0. And then everything below this, so from 5/2 to 3, g prime of x is less than 0. Okay, and you get 3 points for this as well. One is for considering g prime of x is equal to 0. Another one for solving this, and then solving this, and then one more point for having the answer and the justification for it. So now for third part. Find all values of x on the interval -4 to 3 for which the graph of g has a point of inflection, and give a reason for your answer. So once again, I wrote this just to reference. And so first off, we know that for concavity, we look at the second derivative. So we already remember that the first derivative of g of x is 2 plus f of x. So we're just going to take the derivative of that to get the second derivative, and that's just f prime of x. So f prime of x, we're looking at where this graph is going to go from increasing to decreasing or decreasing to increasing. But here, the only spot that happens is at 0. You can see obviously it goes from increasing to decreasing. So that is our only point of inflection. So you have to write that the point of inflection is at x equals 0 because f prime of x goes from increasing to decreasing. And for this whole problem, you only get 1 point, and that is for an answer with reasoning. So make sure you include the reason, otherwise even if you have the correct answer, you will not get the full point. And the last part, find the average rate of change of f on the interval -4 to 3. There is no point c from -4 to 3 for which f prime of c is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. So to start off, we're going to find the average rate of change of f on this interval. And just as a reminder, the average rate of change formula calculates the slope of a line or a curve on a given range. It is defined as the ratio of the difference in the function f of x as it changes from a to b to the difference between a and b. So this is the average rate of change, f of b minus f of a over b minus a. So we know that the interval given is -4 to 3, so we take f of 3 minus f of -4 over 3 minus -4. So once again we reference this graph. So we know f of 3 is -3, right there, and f of -4 is 1. So that's over -3 minus -4, and as we simplify, we get -2 over 7. So that's it for the first part. And now the second part with the mean value theorem. The mean value theorem states that if f of x is defined and continuous on the interval a to b and differentiable on a to b, then there is at least one number c in the interval a to b such that f prime of c is equal to f of b minus f of a over b minus a. And so the problem here with the statement there is no point c from -4 to 3 for which f prime of c is equal to the average rate of change. This is the average rate of change. There is no point c because f is not differentiable at x equals -3 and at x equals 0. So as you can see, at x equals -3 we have a vertical tangent, so that is a problem with differentiability. And then here there are several different tangent points, so that means it is also not differentiable. And so that's it for solving this problem. But I'm also going to suggest that if you need extra practice with this, there are a few other FRQs that you can look at. The first one is 2002, number 4. It has the same setup, very similar. It gives you a graph and it asks for a lot of the same questions. Another one is from 2003 and is also number 4. Same setup, same type of questions. And then once again, 2004, and it's number 5. Graph, setup, very similar.